Hello friends, I demonstrate you insect olfactometer, the installation of insect olfactometer. It contains several parts, the white tube main parts, then PFTV tubings, black coverings, mesh parts, silicon tubings, uh, the humidifier chamber, charcoal chamber, flow controllers, air delivery systems and all. So I'm going to cover each one of it. The compressor unit that we supply along with this unit, it works on 220 volts. If you are buying this unit for the system where 110 volts work, then you have to buy transformer separately. We're not supplying along with this unit. We're not going to supply. That need to be purchased separately. The air compression unit works by compressing the air based on, and the compression of the air happens through the piston based mechanism. You can use the knob actually to control how much outflow you need it. The compressed air is channeled from here into the charcoal chamber. The first one, this one is the charcoal chamber. The once air is entered into the charcoal chamber, the output of air from the charcoal chamber is considered as purified, is sent into the water, where the air picks up the water, and then the humidity turns to be around 80 to 85 RH. So the output of the air from the humidifier system is transferred into the two test chambers. This is the first one, this is the second one. So the first and second test chambers can act as a placement of material like plant material or any other kind of semiochemicals that is drenched in the cotton, or if you want to place any other kind of material that you think that you want to test for this sense. The top-up approach I am showing in here how the air is passing from the compressor air unit into the charcoal unit and then to the humidifying chamber. Humidifier air is divided between two test chambers. So this is one, and then that is the test chamber 2. The output of the test chambers will be used as an input into the air controllers, that is the bottom. From here again, from the chamber 1, test chamber 1, the output air is channeled into the flow meter. The flow meters, the flow regulators has the control knobs. Anti-clockwise and clockwise will increase or decrease the amount of air is coming out. So these indicators let you actually control how much amount of air you are letting into each one of the arm of the white tube. If you turn into the clockwise, you are actually letting the knob inside the flow meters. You are restricting the airflow, so you are reducing the amount of air coming out of the flow meters. The readings are here in liters per minute, so 0.1 liters per minute is 100 ml per minute. So the most suitable LPM is 0.1 to 0.2, at max 0.4. You never require more than 0.5 LPM. The output of flow meters is taken and then directly placed as an input into the each arm of the white tube. Before you connect into the arms, you need to check whether the airflow is really coming out of the system. You have to see that there are no bends of the tubes, either silicon tubes into right angles where the airflow is restricted. So you see here I'm testing the each arm by placing into the water. So the air bubbles are coming out. So it indeed specifies that the test air is coming through the pipes, PFTV pipes. This is the input. We are inputting the air into each arm of the white tube. Yes. Place the white tube in slant position so that insects can walk. they freely walk. Cover the white tube. Once you connect the system, you are releasing the insects, as I'm going to show you right next to this, and then you are going to cover complete system of the white tube with the black cloth. It prevents the external influences of the light on the insect's movement. So it neutralizes any other kinds of error that may introduce while the selection is being happen. Try to keep the white tube in slant position so that insects can walk. They always try to walk in the upwards. Connecting the silicon tubings to the glass couplers. These are the glass couplers. These both act as insect collection chambers as well as the test material placing chamber. So these are the locks. You need to put the lock. You need to find the place, the correct way to find the locking system. If you reverse it, you can't lock that. The locking happens, the smaller side need to be at the coupler side. Yes, now if it reverses, yeah, we can able to fix it. This chamber can act both actually insect collection chamber as well as the now I have placed here the chemical. So when you place the chemical in here, you're going to place mesh between the white tube arm and the chamber, and the coupler chamber. So the coupler chamber now consists of the chemical. The releasing of the insects can either be done through the 50 mm opening, so you can release the insects from here and then cover with the black cloth, or if you think that your sample size is small or your insects are small in size, we can very well cover the 50 mm opening with the black cloth first and then release the insects through the 10 mm hole provision, and then you can plug this 10 mm provision with the cotton plug. So you need to ensure there are no bends at the joints. So where the joints are involved with the silicone pipe, you need to ensure that there is a minimal gap between the two connectors. So in this case I show you that the blue color piping, the hard piping to the glass parts, we need to see that there is as little distance as possible. So there is no distance is more better. If there is a distance, there is a possibility that the silicone might bend into the L shape at the 90 degrees, which constricts the free flow of the air. That put the pressure and the compressor back into the system or also into the glass parts. Please ensure that you press properly the silicone tubings. Too deep inside, yeah, I show you here likewise, there are no bends in the whole system, so you need to follow the same thing throughout the system. Thank you very much.